is the topic changing the subject of a formula. And the technique for doing this is the same as you would do in equations. Whatever you do to one side, you do exactly the same to the other. Now what I'm going to do is I'm going to start off with part one and talk about part one in terms of where we have seen similar maths before. So all I've done is copied out the question, px minus q is equal to r. This is a lesson in reading. You have to read the question. And when you read the question, what you will see is that they've asked you for something very specific. They've asked you to express x in terms of everything else. So what they're saying to you from the very outset is, for part one, they eventually want x equals something. So x is the letter, and you pretend, based on your past experience, that everything else is numbers. So you go through this. Now, if you're shy about talking, it's a thumbs up for staying, and it's a thumbs down for moving. So what you have here is this term here, px, is it staying or is it moving? So it's what we want. We want to find x. So is it staying or is it going? And it's staying. And the reason why it's staying is because we want to isolate the x on the left-hand side. It's the thing we're looking for. Now, what I'm doing over here is I'm using prime numbers to set up some scaffolding. And what you might have noticed is that I have actually put in, whoops, that's meant to be a 5. Oh, that's meant to be a Q. That was meant to be an R. I've put in 3 for P, 5 for Q, and 7 for R. And what I'm doing there is basically, this is what you've had before. And the question says, find the value of x. So what do? Does the 3x stay or go? And it stays. So does the px stay or go? It stays. So then you ask yourself the question, what's q? Well, q you now treat as, or minus q, sorry, you now treat as an ordinary number. So does it stay or go? And if it was a minus 5, does it stay or go? So what does it do? Does it stay or does it go? And it goes, because we're pretending, it's not algebra for this problem, it's a number that needs to move to the other side. So we now recognize that the minus q has to move to the other side. Why? Because it's not involving an x. So anything that's not involving an x goes to the other side. So what about the r? Is it staying or is it going? And it's staying because it doesn't involve an x, and so therefore it's on the correct side, so the plus r is now staying. If we look at what we've already been doing quite successfully, what we've just done is basically that. And of course, if it was ordinary algebra, we could tidy up the right-hand side. 5 plus 7 is 12. We can't do that with a q and an r. They're separate entities. They stay as q plus r. But if it was 3x equals 12, what would I now be doing to the left-hand side? Go on. Dividing by 3. And whatever I do to the left-hand side, I do to the right-hand side. So I want to get x on its own. So what's happening to the x? It's being multiplied by the p. So what have I got to do to undo it? Anyone else? What do we have to do? Divide by p. Because to undo a multiplication, we have to do a division. But whatever we do to one side, we must do to the other. So now the p and the p cancels out, and we're left with x equals q plus r over p. Now, there's something in mathematics called partial fractions. And basically, you've got q plus r divided by p, or you can write it as q divided by p plus r divided by p, where you can split it into its separate fractions. And that's the end of part 1. Now, can you see how I've used scaffolding to help you focus if you have any doubts as to what to do? Why did I choose prime numbers? Because I know that they're less likely to look the same. You know, they're distinct, very distinct numbers. So that's the end of part 1. So what I'm going to do now is part 2. So I'm going to rub this out, and we're going to do part 2. So part 2. What do I have? U squared plus 2as is equal to v squared. What's the letter I am trying to isolate on its own? It's an exercise in reading. I need more hands than that. I need more hands than that. So what's the letter that we are trying to isolate? What do they tell us that we're trying to isolate? S. We're trying to isolate the S. So this is what we're trying to isolate. So we're going through our staying or going. So the first thing we focus on is the S. So here it is it staying or going? Nice bit of a shout out here. Is it staying or going? Staying. It's staying. So we've got 2as is staying, because S is the X. Happy with that? Now, the U squared, does it involve an S? No. Staying or going? Going. Hang on to that notion for a moment. Is this one staying or going? Staying. It's on the other side already. It doesn't involve an X, so it doesn't travel across. So that V squared is staying. And what do we say about this one? Going. So what does it become? Minus U squared. A show of hands if someone is a bit wary about that, and be honest with me if you are, because I'll show you the scaffolding technique. I might just show you anyway. U squared plus 2as is equal to v squared. That is the only variable. That's like in the old days being a x. This thing here is just an ordinary number, which we'll call 3. There's a plus sign. This is an ordinary number, which we just call 5. And the v squared is an ordinary number, which we just call 7. And then you can quite plainly see that this is staying, this is going to the other side, and this is, you see what I'm getting at? It's a way of helping you focus in a moment of panic. Now, I'm not recommending that you use it all the time. If you can get out of the habit of using the scaffolding, it means that you are developing higher level of thinking. You are coming to terms with reading algebra in a different way. What do I want to get on its own is the S. This is now where you can participate. What do I need to get rid of? If I want the S on its own, what do I have to get rid of? Nicole? Sorry, didn't mean to use names, but doesn't matter. The 2a. The 2a. And so how do I get rid of the multiply by 2a, which it currently is? You just divide by 2a. Now, so I'm going to divide this by 2a. Now, you saw last time where I put a line all the way along. I'm going to keep doing that because I think that's what the book does. But you could have just divided each bit by 2a. And if you divided each bit by 2a, I'll just do it over here. You can skip. So divide this by 2a, divide this by 2a, and divide that by 2a. That cancels. That cancels. Now, s is equal to v squared minus u squared over 2a, or we can use the partial fraction technique where the first item can be divided by 2a, then we put the minus sign, and the second item can be independently divided by 2a. It's a technique which is used in 5th year and Leaving Cert a lot, which is the reason why I'm emphasising it now. How was that? Yeah? Okay, so what we need to do now is just, obviously it's going to be on the video, so you know, you can, if you don't finish a line off here, you can scrub through the video, find that line, focus on it, listen to what's being said. So if everyone is in agreement, I'm just going to wipe that again, and we're going to look at part 3. Now, if all you do out of this unit of work for today is study these examples, I'm not setting many questions, and get a small number of the questions done, which we decide in a few minutes, then that's a good thing. So what we have now is just wipe this page, and we're going on to part 3. So the first thing is, this time I'm going to write down what part 3 is, and then I need you to have read it and tell me what is the focal point. What is the focal point for this one? Yeah, it's the T. Now, and it occurs in 2 different positions. Now, when it occurs in 2 different positions, no element of fear, because this is a distinction level question. So if you're getting something right on this, you're doing very well. You get most of it right, you're doing extraordinarily well. If you can finish it off, it's a distinction standard question. If you can build mathematics like this into a CBA, then you are getting the top grade within the CBA. So you're looking at this thing here and you say, right, okay, is my immediate problem finding the T? And I don't think it is. What's my immediate problem? Yeah. Getting rid of the fraction, getting rid of the 3t. How do I get rid of a divide by 3t?
Multiply by 3t.
And we multiply everything by 3t. Now let's do that in a slightly different colour down here. So it's 3t multiplying everything, because the first priority is to get rid of a divide by 3t. But whatever we do to one side, we have got to do to the other. So you haven't seen this in a while, but we'll just quickly, it's the arrow method. So it's going to be 3t on p. So it's 3tp equals 3t on. Now, because it's a double item, we have got to introduce brackets, because it's 3t on q minus t. And you have to introduce brackets. Now, they are slightly unnecessary, but mathematically you have to do it, because guess what we're going to do immediately now? The whole point of this exercise was to cancel out the 3t on the bottom, to undo the 3t. So we now know that this cancels out, and we are now left with 3tp is equal to, well, there's nothing in front of that bracket to multiply anymore except 1. So therefore 1 on q minus t is just q minus t. Don't lose sight of the fact of what we're looking for. Because now that we've got the line with no fractions, we're down to the staying or going. So a bit more people involved in this. What's this one going to be? Staying. So that's going to be just left there. And before we put an equal sign in, we have a look along. Because what are we looking for? We're looking for the t's. And we found it. It's the minus t. So what's it going to be doing? It's going to be going over. It's going to be going. And when it goes over, what's it going to become? A plus. So it's going to become a plus t. And then we still don't put the equals in yet, but I think we can, can't we? Why can we put the equals in? There's no more t's. So the equals goes in, there's no more t's. And what do we say about the q? It's staying, but it doesn't involve a t. So that q is staying. Now, as you notice, we've got to the bottom of the page. Now, because I've got a bit of leeway here, I don't want to lose the questions at the top. There are students who have problems with this all the way through to Leaving Cert. Now, the good thing about this, it's on video. So you can go back and look at this again and again. But what you've got to learn is, you've got two terms with t in it. And the trick with this activity is you've got to get the t on its own. And in order to get the t on its own, there is only one method on your course. We have to get the t on its own. We have to isolate it. And there's only one way to isolate an algebraic expression in mathematics. Only one way. And the method is quite simply factorization. Factorization. We haven't done that since the start of the year. And what we've got is we have a common factor of what we want to isolate. And the common factor is a t. We don't even bother with the highest common factor. If it had been a 3t there, we wouldn't even bother with it. We just focus on the t itself. And when we factorize in mathematics, we bring the t to the front and then we create a bracket. So what's left? If I've brought the t out from the first term, a few more hands, what's left? Come on. Michael? Sorry, name again, didn't mean to do that. It's 3p, well done, excellent. Plus? 1. Yes, it is. Because what do we have to remember? If there's a letter on its own, what technically is the number in front of it? 1. So it's 3p plus 1, and that's still equal to the q. Now, clearly I am running out of space. The rule in maths is if you're running out of space, try and use as much available space as possible, save the trees, and move it across, but always rewrite the line. Do not do it, rewrite it. What have I got to do to isolate the t? I've isolated it as a single letter, but now I need to isolate that single letter completely. Anyone? Anyone? I know you're okay. Go on then.
Divide by 3p plus 1.
Yeah, because we divide by what's in front of it, or in this case, what's behind it. Now, I think we're good enough after last example just to reach for a different colour and put 3p plus 1 on the bottom of both sides. I can also get away with it because I've already written that line down there. So I've got the grade boundary mark for that line already. Probably a good idea to put brackets around it. Of course, the very next thing we're going to do in pencil is cancel it out, and then we're left with a t is equal to q over 3p plus 1. Now, this is not a partial fraction. You can't put q over 3p and q over 1. You can only do partial fractions when there's a single letter on the bottom. And that's what happened in the other two examples. we haven't got a single item on the bottom. We've got two items, a 3p and a +1. So that can't be simplified any further. That is it. And that's the end of example 1. And that's the hardest question there. Now, I did note when I looked at the exercise earlier, these are the same questions I set on page 1. But in order to do these questions, I think I've done enough. But you know what? This is a slight variation on some of the ones the last one you've just done. What are we looking for, and what's our immediate problem? That is a question in 2 parts. What are we trying to isolate, and what is the immediate problem? So what is the letter that we are trying to isolate? All of you should have a chance to read it now, so there should be, everyone's hand should be up. Everyone's hand should be up. I've already called out 3 names, so I haven't called out surnames, so that's probably a good thing. Edgar? Yeah, so straight away we want to emphasize that some way down this problem we need to be starting to focus on the Q. Now, that is not the immediate issue. Yeah? I mean, I might want to build a house. That's not the immediate issue. The immediate issue is making sure a good foundation goes in. Yeah? So we know what we want to get to. We want to get to the Q. What's our immediate issue? More hands than that, more hands than that. Come on, don't be shy. You know this, you know this, you know this. You know this. EL? Owen? Yeah. What's our immediate problem? Oh, it should be crying out to you because no one likes them. What's our immediate problem? What's our immediate problem? Come on, a few more hands, a few more hands. Come on, a few more hands. Leah? Fractions. It's the fractions. So, Owen, how do I undo fractions? Well, a fraction is a division. So how do I undo a fraction? You multiply. So how do I undo a divide by 2? You've been doing it. You've been doing it for the simultaneous equations. You multiply by 2. You with me? So how do I undo a divide by Q? How do I undo a divide by Q? Nathan? You multiply by Q. But I've also got a divide by R. So how am I going to undo a divide by R? Leon? Multiply by R. So what am I multiplying by? Q. I'm multiplying by a Q and I'm multiplying by R. So, once again, it's probably a good idea for the example I'm going to be multiplying by QR. What am I going to be multiplying it onto? I'm going to be multiplying it onto the expression, or the equation actually, above. Now, I'm going to keep this simple. I always do. So I'm going to do a QR on the 3p. I'm going to do a QR on the 2 over q. Then it's a minus sign, and I'm going to do the QR on 1 over r, using the dot notation for multiplication. Let's deal with it bit by bit. When we look at the first term, we've got 4 items, Q, R, 3 and P. Convention is number first, isn't it? And then after that, it really is up to you. But generally speaking, it's alphabetic. But I'm just going to... I know it's not alphabetical, but it doesn't matter. Now, what was the whole point of the second term? Wasn't it so that we could cancel the Q with the Q? And don't forget the convention, numbers first, algebra second. And then on the next one, get the pencil out, cancel out the R's, and number first, which is a 1, and it's a 1 on Q. So we've actually got to the point where it's no longer a fraction. We can now focus on what we're looking for, and we've already got it highlighted in the bubble at the top, and what we're looking for is the Q. So, what do we do now? It's looking at a staying or going situation. So, staying or going, that could be a huge shout out from you all. Staying, because the Q needs to be on that side. And I don't go to, what's the next thing I immediately go to? I go to the next Q. And I'm saying to myself, fairly obviously now, staying or going? Going. So what's it become? Plus Q. So plus 1Q. And then finally, I've got to put a tick beside the 2R. Does it have a Q on it?
No.
So what's it going to be doing? It's going to be staying on that side. But the problem again, what do we have? No harm using the highlighter. We've got a Q in two different places on the left-hand side. There's only one method on your course for doing this. This is a distinction question. What is that method? Michael? Factorize it. So, but we're only going to factorize out the Q. Now, in this case, that's all we can do. So I'm going to factorize out the Q, and what's left behind? What's left behind? Adam, what's left behind? 3RP plus 1, close bracket, is equal to 2R. And then we're back to what we've always back to. If we had 3x equals 7, 3 times x equals 7, what do we do to undo the multiply? We do a divide, and we do it to both sides. So what have we got to do here? What have we got to do here, Kyle, to sort this out? What do we have to divide by? Well done, you. So now, because I'm a bit lazy, I will put it in a different colour. Probably would do that in an exam as well, just so as I can see more clearly if I've got it right or wrong. Whatever I do to one side, I do to the other. The black and the blue are going to cancel on this side, so get the pencil out and just cancel it out. And then what we end up with is Q is equal to 2R over 3RP plus 1. And now you should be able to do those questions.